Hello, everyone. It's Mr. Kissinger at the Citizenship Academy in Syracuse, New York. This is 5th grade math, module 3, lesson 12. Today we're going to be subtracting fractions greater than or equal to 1. I'm going to show you two different methods by which you can do this. So we'll start on letter A, and this is going to be the first method. I have already written 3 1/5 minus 2 equals 1 1/5. What I've done is I've taken that 3 1/5 and I've subtracted out my whole number. And it gives me 1 1/5. Now I need to subtract my fraction. So I have 1 1/5 minus 1/4. So the first thing we're going to do is, just like we've done in lesson 11, is we have to find a like denominator. My like denominator between 5 and 4 will be 20. 5 times 4 is 20. It's the lowest denominator that we can find in common between the two of them. So I'll need to multiply by 4 here and multiply by 4 on my numerator. I'll end up with 1 4/20. And then 1/4, we need to multiply by 5 to get to 20. We need to multiply my numerator by 5 as well. And we're going to end up with 5/20. And here's where we're going to run into a little bit of an issue. And I know we did this in the last word problem in lesson 11. We have 4/20 here. We need to subtract 5/20 from it. So we're not going to be able to do that right away. I need to change this 1 4/20. And the way I'm going to do that is, I know that 1 is equal to 20/20. Just like regular subtraction, I'm just going to borrow some 20ths from my 1. Plus 4/20. And then minus 5/20. So I'm going to start up here to give myself a little more room. And I have 20/20 plus 4/20. Now I have 24/20 here minus 5/20. So now I can subtract 24 minus 5 is 19, and I end up with 19/20. And that's my answer. So that's very similar to just regular subtraction. We're just using kind of a borrowing type method. We're going to take our whole number and we're going to turn it into a fraction. We also have a method that's called an open number line. So I'm going to start by drawing a number line here for letter B. And on the left side of my number line, I'm going to write my smaller of the two numbers, my lesser. So I'll have 3 3/4. And up here, I'm going to put 4 2/5. When I subtract, I'm really looking for the distance between these two numbers on a number line. I'm looking for the difference between those numbers. Difference means subtraction. So if I can find out, if I can jump from here to here and I can add up all of my jumps, I'll have the difference between those two numbers. So if you like adding more than you like subtracting, this might be the method for you. What I'm going to do first is I'm going to get to my next whole number. So I'll take 3 3/4 and I'm going to jump to 4. How much do I need to add to get from 3 3/4 to 4? Well, I need to add one more fourth, because 3 4/4 would be 4. So I need to add 1/4. To get from 4 to 4 2/5, what do I need to add? Well, I need to add another 2/5. 4 plus 2/5 is 4 2/5. And now I just need to add up these two jumps. So I'll do 1 and 1, or I'll do 1/4 plus 2/5. I'll find my common denominator. Again, 4 and 5, it's going to be 20. Multiply my 4 by 5. Multiply my numerator by 5. And I'm going to end up with 5/20. And then I need to multiply 5 by 4 to get to 20. I need to multiply my numerator by 4. And I get 8/20. Now I just need to add 5/20 plus 8/20. And I'll get 13/20. And there's my answer. Next, letter C, we'll go back to our first method. We have 7 and 1/5 minus 4 and 1/3. Well, let's take 7 and 1/5 and subtract 4. We get 3 and 1/5. And then 3 and 1/5. And we need to subtract 1/3. We'll have to find a common denominator between those two. And it's going to be 15. 5 times 3 is 15. 3 times 5 is 15. So I do that to both my numerator and my denominator. I'm going to get 3 and 3/15 minus 5/15. So my 3 and 3/15, well, I can't subtract 5/15 from 3/15, but I can turn that 3 and 3/15 into something else. I'm going to need to borrow from one of my whole numbers here. But I don't need to make 3 into 15ths. I only need to make one of those wholes into 15ths. So what I'll do is I can really make this 3 into 2 and plus 15/15. 15/15 is the same as 1. So 3 and 2 and 15/15 are equivalent. And then I need to add my 3/15 that I already had. And I'm going to subtract 5/15. So 15/15 plus 3/15 is 18/15. I'm going to move this all up here. 18/15. I have my 2 and 18/15 minus 5/15. And now I can subtract. And I'm going to end up with 2 and 13/15. All right. So let's do letter D with our open number line. I'm going to draw myself a number line up here. And here on my left, I have 5 and 2/3. Remember, my lower number, my lesser number on my number line always has to go on the left of the number line. Numbers always go up, left to right on a number line. So just because this 7 is on the left side doesn't mean we're going to put that on the left side of our number line. And then up at the top here, we will put our 7 and 2/5. To get from 5 and 2/3, I'm going to jump just to my next whole number. And I know I have to go 1/3. 5 and 2/3 plus 1 more third would get me to 6. And then to get from 6 to 7 and 2/5, I have to go 1 and 2/5. So now I have, and I can do this in any order because I'm adding. So I'm going to start with my large number. You could add 1/3 plus 1 2/5. I'm just going to do 1 2/5 plus 1/3, so my fractions are closer to each other, make it look a little bit neater to make it easier to see. I have 1 2/5 plus 1/3. You're going to have to turn the subtraction problem now into an addition problem. I multiply by 3. And then this one I'll multiply by 5 because I'm trying to get 15 on my denominator. I have 5 times 3 is 15 and 3 times 5 is 15. Anything I do to my denominator, I also have to do to my numerator. I'm going to end up with 1 6/15 plus 5/15. And I'll end up with 11/15. All right. Let's try this word problem down here. It says, Toby wrote the following. 7 1/4 minus 3 3/4 equals 4 2/4 equals 4 1/2. Is Toby's calculation correct? Draw a number line to support your answer. Let's use our number line here. And we're going to put 3 3/4 on one side. And we're going to put 7 1/4 on the other side. So we'll use our open number line method since it asked us to draw a number line, and we'll see if Toby's correct. 3 3/4. Let's jump to the next whole number. We have to add one more fourth to get to 4. And then I'm going to add, I can add an extra jump too if it makes it easier. I'll go up to my nearest whole number. I'll go to 7 here. I jump 3 here. And then I go another fourth to get to 7. To get to 7 1/4. So now I need to add all these together. I have 3 plus 1/4 plus 1/4 equals, and we can already see that we have 3 2/4. And 2/4 is equivalent to 1/2. I can divide each by 2. And I get 3 1/2. So I'm going to answer no. Toby's calculation is not correct. And that's all it asks us to do. Go back to the question. It says, is Toby's calculation correct? I said it is not correct. We drew a number line to support our answer. Right, here's our number line that shows that we have a jump of 1/4, we have a jump of 3, and another 1/4 in between 3 1/4 and 7 1/4. But 3 3/4 and 7 1/4. So that is all we are going to do for today. Thank you guys so much for tuning in, and we'll look forward to seeing you next time.